Today we're going to start looking at graphing quadratics. We're not actually going to graph today. We're going to do a couple of the pieces for graphing. And the other topic that we're going to graph in here, we're going to graph exponentials next week. And they have very different processes, but whoever writes your final exam really likes graphing. So make sure you know how to draw the graphs. You'll have to draw one of each of these on your next unit test as well. So you'll have to draw one quadratic, you'll have to draw one exponential on your next unit test. So when we graph a quadratic, it's been a long time. How do I know when an equation's quadratic generally? What do we look for? Squared, a squared term. So I ask you all the time, what type of equation is this? If we see the x squared, we say it's quadratic. So we're used to seeing this form right here, at ax squared plus bx plus c. We've seen that as far back as factoring. Now there is one other form of a quadratic, which we're not going to do a whole lot with, but it has its practicalities, and that's this form right here, where you have a and then parentheses x minus h squared plus k. A, h, and k are all numbers. So a, h, and k, these guys are all, they're numbers. So it's just another form that you could use to graph a quadratic. We're going to draw the full graphs only from this second form, but we'll find one specific point from this form. So if you graph a quadratic, what's it look like? And we got this down here. So you get what is called, the shape is a parabola. So the shape of a quadratic is a parabola. And there's two ways it can open. You either got the cereal bowl parabola or the rainbow parabola. This is the cereal bowl parabola. We can, if we just flip that over, that's the other type we can have. And go ahead and put some arrows. This isn't the best graph, because that graph does continue, which is important when we get into talking about the domain and range. So there's a bunch of very specific points we need to graph a quadratic. If you graph lines in 082, you could find any 2 points, connect them, you've got a line. But if I find just a random collection of points for a quadratic, I'm not necessarily going to get a very good picture. Because what if all my points were right here? I wouldn't see this hole, it comes down, it turns around, it goes back up. So the specific points we're going to want, you will always have a y-intercept. There will always be one of those. You may or may not have x-intercepts, and on Friday we'll see all sorts of examples where you have 2, 1, or no x-intercepts. You will always have a vertex, and this is what we're going to do today. We're going to really look at the vertex. That's either the bottom of the graph, or if I flip this graph upside down, the very top of the graph. So it's the maximum or the minimum point. And that also comes in a lot with word problems, and the people who write your final like word problems. So we're going to talk about a couple of those today. And then you'll see I've got this dashed line that cuts right down through the vertex. It cuts the graph in half. This dotted line or dashed line is called the axis of symmetry. Hopefully that's how you spell symmetry. I'm a horrible speller. So you can only get some great qualities. I'm really good at math. I'm horrible at spelling. And what that means is if I had this on a piece of paper and I folded the paper in half, the two sides of the graph would line up. It's symmetrical. So how far this point is from the middle, it's equal distance to this point. How far this point is from the middle, it's the equal distance to the point on the other side. Every point has a point that's equal distance away. So we can use that axis of symmetry when we start graphing to put in some extra points kind of for free. If we know a point on the left, we just go the same distance from the center to the right. We're guaranteed another point there. So we'll use that on Friday. We're not actually going to use that today. So here's a couple of examples of a quadratic. When you graph it, you get a parabola. And the first thing we're always going to talk about when we graph is, does this graph open upward or downward? So if we're looking at that ax squared plus bx plus c most of the time, if a is greater than 0, which this is saying that a is positive, we get the cereal bowl parabola. It opens upward. If we have a less than 0, which is the fancy way of saying a is negative, it opens downward. So we'll always have an idea right away going into this what our picture should look like. And if we can't connect our points to make that picture, we might have something wrong along the way. Now the vertex on these graphs, the vertex is always the very bottom point, so here's the vertex, or the very top point if we're opening downward. There's our vertex up there. So the vertex is always a minimum or a maximum. So there's a couple questions on your homework. There's 39 and 41. Ask you, just by looking at a graph, do you have a minimum or maximum? Or sorry, just by looking at an equation, do you have a minimum or maximum? Well, if you know that your graph opens upward, then you know the vertex is a minimum. It's going to be at the bottom of your graph. But if you look at your graph and you see that it opens downward, without even drawing the picture, you can say that the vertex is a maximum. It's going to be the highest point. So when you get to those questions, that 39 and 41 on your homework, and it says, does this graph have a minimum or maximum, and it just gives you the equation, what you're looking for is, does it open upward, so it's got a minimum, or does it open downward, so it has a maximum? And then the other thing we want to talk about for these graphs and for all the graphs we're going to draw are domain and range. So I have a little recall. Our domain is a set of all the first components. It's going to be the span of our x values. So we're going to use those parentheses and those brackets to say start here, go here. And the range is the set of all second components. It's the span of our y values. So for the domain and range on these, we are going to be using interval notation. So when you talk about the domain and range of graphs, unless your graph is just points, we use the interval notation. Well, the nice thing about quadratics is the domain is always the same, 100% of the time. I can plug any x value in, and I get back a y value. So if I'm looking at my graph, you'll see the continues to get wider. We have to think outside of our picture, but the graph continues to get wider on the left side and wider on the right side, which means it covers all of those values, all of our x's work. Our domain is always negative infinity to positive infinity. Doesn't matter if it opens up, doesn't matter if it opens down, doesn't matter where it sits. Our domain is always negative infinity to positive infinity. So there's no problems. There's no holes in our domain. So other times we looked at the domain, we said, okay, when's the denominator 0? That's a problem. When is our square root negative? That's a problem. For quadratics, there are no problem areas. So we can include any x value. Now the range is going to change for every graph. And when we look at the range, we want to focus on the vertex. So we're going to focus on the vertex, because we want to see where's the bottom of our graph and then where's the top of our graph. So we talked about this a while ago. It's the bottom and the top y values. And remember, they could be parentheses or the square brackets, depending on what, whether we're including them or not. So like if I look at this first graph, do I have a definite bottom to this graph? Is there a point where this graph stops? We have a bottom. Okay, so I'm interested for range. It's always the y values. What's the y value at the bottom of my graph? Negative 3. So if I go to the bottom of the graph, the y value there is negative 3. Now the vertex is actually on that point, so what's my notation is saying include that number? The square, yeah, the square brackets. So the bottom of that graph has a y value of negative 3. We found here's the bottom, doesn't go any further below that. The y value is negative 3. Now we're looking for the top of the graph. So I'm going to look up. I got those arrows, it's going forever. The graph continues to go up and up and up beyond what we can draw on our picture. So the top of that range is up at infinity. And am I including infinity? Nah, parentheses always for those infinity. So the vertex is going to come into play in your range. The domain is the same 100% of the time. But for your range, you're looking for the bottom of your graph first and then the top of your graph. Sarah? Yes, yes. The range is always the y-axis. On graphs in general, whenever you want domain, you always look on the x-axis, and whenever you want range, you look on the y. Yeah. Good question. Now, it's really important that you look for the bottom of the graph first and then the top of the graph, because people get excited when they find a number and usually put that first. But if I look at the second graph, where's the bottom of this graph? Keeps going. It's going and going and going. So the range starts at negative infinity. If you can't find the bottom, it means it's going down forever. You're going down to negative infinity. Where's the top of this graph? Looking at the y value at the top, which is 1. So this one didn't have a set bottom, but it had a set top. And that's the difference between opens upward and opens downward. So if it opens upward, we have a minimum. That's where we start our range. If we have it opening downward, since it goes down forever, we start at negative infinity and then we go up to our maximum, which is our vertex. So the vertex will always come in to play when you're looking at the range. And we'll get more of those on Friday when we graph. Any questions so far? All right, so here's our laundry list for what we need in order to graph a quadratic. We first want to know, does the parabola open upwards or downwards? We need the vertex, which is what we'll spend all of today finding. We need the x-intercept or x-intercepts. If they exist, the y-intercept always exists. And then optional, we can use the axis of symmetry to graph a point symmetric to the y-intercept. If we don't have x-intercepts, we don't have much of a picture. So we're going to really use that axis of symmetry. But again, that comes more on Friday. Today we're going to focus on the vertex. So our first little section here, determine whether the graph opens upward or downward. All you have to do is look at the sign of A. And it's the same A as with our factoring, the same A as with our quadratic formula. So if I have f of x equals 2x squared plus 6x minus 9, all I'm doing is looking at the number in front of x squared. If it's positive, so A is greater than 0, it's positive, it opens upward. So does this graph have a maximum or minimum? Minimum. And if you're not sure, I always suggest that you just sketch, okay, if it opens upward, it's the cereal bowl, which means it's got a bottom point, which means it has a minimum. And again, that's the kind of concept question that's in 39 and 41 on your homework. So if I look at B, what's the value for A and B? Negative 1. So since A is negative, which mathematically the fancy way is you say it's less than 0, since it's negative, we know it opens downward. So does this graph have a maximum or minimum? Maximum. And if you're not sure, just sketch the little picture. Okay, it's got a point at the top. So it has a maximum. Yeah.
Does that mean that when it's downward, that it's
Negative infinity first all the time. Yep. And then you just look at the y value of your vertex, and that's the max. And then C, is that one open upward or downward? Upward, yeah. A is 1, which means it's positive. Oops. So it opens upward. Does it have a max or min? Minimum. So every graph, every parabola that opens upward has a minimum. So if you just look at an equation, you can tell me if it has a maximum or minimum, a quadratic equation, based on whether it opens upward or downward. So what we're going to do now is we're going to find those maximum and minimum values. We're going to find the vertex. So find the coordinates of the vertex defined by the quadratic. Does the function have a max or min value? So I think the question on your homework says, does it have a max or min value? Find that max or min value. If you're ever asked for a maximum or minimum from a quadratic, it wants the vertex. And that's important in our word problems. If you have a quadratic and it asks for a max or min, you want the vertex. So we're going to first be in this form. So remember, we have two forms that we've got to deal with. This set of directions is specifically for anything in the form ax squared plus bx plus c. And this is one of those little formulas that you have to memorize. So what are we up to? We had the little formula for completing the square, formula for quadratics, solving quadratics, quadratic formula, and now you have vertex formula. I think those are the only ones that we have. And this is your formula. So if we're in that form, we're going to use our formula x equals negative b over 2a. And it looks a little bit familiar. Where have we seen something that looks kind of like that? It's a truncated version of something. Yeah, it's the quadratic formula without the long square root on it. So they're related. So two things I need to know what A and B are. So to find the vertex, I need A and B. So what's A in this problem? 1. It's the same A as we've been working with. And B? 6. So I'm going to go to my little formula. And I know that x equals negative b over 2a. I'm going to substitute my numbers in. So I have negative 6 over 2 times 1. Again, watch out for those double negatives popping up. But there's just one here. So I have negative 6 over 2. It gives me negative 3. Now, the vertex is a point. So this is just half of a point. This is just the x half of a point. I also need the y half of the point. So to find the second half, all we have to do is plug it back in. So I'm going to go back to my original function, and everywhere I had an x, I'm going to replace it with negative 3. So to find the y value, we're going to take our x value from number 1 and just substitute it back in. So we're looking at f of negative 3. We're just going to take all of the x's and replace them with negative 3's. Because points have both x and y. If you're using a calculator, make sure you use parentheses. We're looking at negative 3 squared is 9. Minus 18 plus 5. And when you get to addition subtraction, work left to right. So 9 minus 18 is negative 9 plus 5 is negative 4. So the vertex is a point, so put it in parentheses to show it's an ordered pair. So that's my vertex, and the point, negative 3, negative 4. So we use our little formula for x, and then we just take that answer and plug it back in. That tells us the point that is our vertex. Now for this particular graph, is that going to be a minimum or a maximum? So the first question is, does it open upward or downward? Upward. So once you know it opens upward, you have an idea, and if you're not sure, just draw a little parabola that opens upward. Does that point have a lowest point or a highest point? Lowest. It's got a minimum. So this vertex in this problem is a minimum. Yeah.
Is that because the A is 1 and that's positive?
Yes. Yep. That comes right from here. It has nothing to do with the actual point. Yeah. So you can actually answer that question before you even start. It has nothing to do with the coordinates here. It has everything to do with the value of A. And again, and I'm just pointing out because the directions are funny. On 39 and 41 on your homework, it's going to ask you, do you have a maximum or minimum? So is your vertex at the top or bottom? And then it says find the maximum or minimum. It's just asking you to find the vertex. If you're ever asked to find a max or min on a quadratic, you're looking for the vertex. So here's our next example. So let's do this one. Let's find our max or min before we even solve the problem. So does this graph, does this quadratic in B have a maximum or minimum value? Minimum. It's got a minimum again. So we can tell just by looking at A, because A is positive, that it opens upwards, so it has a minimum. Can't stress how much those two are related. Quadratics will either have a max or a min. It's all based on opening up or down. And that point is called the vertex. So the other thing we need when we're in this form is we need to know B, which is -9, and then we can use our little formula to find x, and that's x equals -b over 2a. So let's substitute in our numbers. We have a negative, -9. So there's a negative in the formula and a negative on our number. All over 2 times 1. Which gives me +9 over 2. And I would go ahead and divide that out. Since we're working with a point, you don't need a fraction. 4.5. But that's just half of my point. That's just the x half. Where do I find the y half? Plug it back in. So we're going to go down into my function and plug 4.5 in for x. So 4.5 squared minus 9 times 4.5 plus 18. Looking at 20.25 minus 40.5 plus 18. And you can do this all at once. I don't need you to necessarily write out each of those steps. I got -2.25. So you need the formula for the first half, and then you just plug it in for the second half. So my vertex we write as a point. That's the point 4.5, -2.25. And that is the minimum of this graph. You never get below that value. Yes, because the first number you get is always x, and in an ordered pair, x always comes first. Yeah, in our ordered pair, we go x and then y. So the formula gets you x, and then substituting back in gets you y. Any other questions? Go ahead and try C. Tell me if I have a max or min, and then find that maximum or minimum value, which is asking you to find your vertex. All right, impressed with your sign usage. This one's a little trickier because of that negative in front of the x squared. If I put a negative number in front of x squared, it's not a problem. But first, do I have a max or min? Max. This one opens downward. So if you're asked, do you have a max or min on a quadratic, you're just looking upward or downward. It's got a maximum. So for our vertex, we use the little formula for x. So if we substitute in, we have a is -1 and b is 2. -2 over 2 times -1. It's -2 over -2, which gives me 1. What did people get for the y value? There's 2 y values that I expect to see. Only one of them's correct. 3, I got 3, 1 or 3. 1 or 3 are the ones that you would, I would expect to see. Only one of those is correct. And it's all based on parentheses. So remember I said be careful when you substitute this 1 back in, I'm putting it in place of x. So the number in place of x is 1, not -1. The negative's got to hang out front. It's not part of the number. It's part of the expression there. And then plus 2 times 1. And this goes back to Unit 2 where we talked all about the importance of negatives and parentheses. I'm not squaring -1. I'm squaring 1, and then I want the negative of that. So this is the one time where you can get that negative value from a square because the negative's out front. So it's -1 plus 2, which is +1. So my vertex is the point 1, 1. So you got to be careful if you have just the negative in front of your x squared. If you have just the negative in front of your x squared, it stays outside of the parentheses. So whatever you square will be positive, drop down the negative sign. So any questions? That's the one part that's a little tricky about this one, where the negative goes. So the other type of quadratic, this is the last thing we'll do today. We'll save the word problems for Friday. If you have this form of a quadratic right here, finding your vertex is like that. There's no formulas, there's no plugging in, there's no solving. You can find your vertex just by looking at it. This only works, only works if you have this funky form right here, where you have the parentheses, you have something squared, you have the number added on the end. If I give you something in this form, ax squared plus bx plus c, you can't just look at it and find the vertex. You have to go through the formula process. We're not going to do anything with this form of a quadratic other than identify the vertex. But just so if you go on to another class and they want you to have seen this before, we've looked at it. So if you're in this non-standard form, you can look at it and tell me your vertex. What you do is the x-coordinate is h, so you look at this number here with the opposite sign, and then the y value is the number on the end, as is. So what you're looking at, so do we see how these look different? These look pretty different than the ones we've been working with. These are the easy form for the vertex, but not for everything else. The only thing that's simple about these is the vertex. But look at the form of this compared to these ones up here. And just notice how they're different. Different process for a different form. All you're going to do is look at the number that's with the x, flip the sign, look at the number on the end, keep the sign. So the vertex is +1, +6. Which is why this form can be useful. Because you can tell right away where the max or min is just by looking at the numbers there. Versus having to do the formula like on the other form. So if I look at B, first of all, does this open upward or downward? What do you think? It's still upward. A, look at the form. A is the number in front. So A in this one is 2. So the number out front is still A. So you can still look at that A and tell me max or min. But to find the vertex in this funky format, it's really easy. You just flip, keep. So the vertex is the point -3, -2. No work needed. But you can only do that if you have this funky format, which you could make through completing the square. We're not going to ever do that, but you could do this yourself. So C, what's my vertex? 1, -10. So we flip and we keep. So the vertex is the point +1, -10. So this format is good for the vertex. It gets a little trickier. You've got to do the square root property and other things if we wanted to find our intercepts and such. So the only thing we're going to do in this format is find the vertex. Most of the time we're going for this ax squared plus bx plus c. So So if you're asked to find a max or min, what's that point called? On a quadratic, the maximum or minimum point, what's it called? Vertex. Vertex.